The following has been developed by state and provincial educational agencies in association with the Agency for Instructional Technology. Together, programming for today's learner.
Okay, Chelsea, what we want to do is hit the one ball with the cue ball directly opposite the pocket. See?
Well, Uncle Bill, kind of, but it was pretty fast.
Well, the key thing is the angle.
Angle?
Yeah, an angle is where two lines meet at a point.
So what are the two lines here?
Well, one line runs from the center of the pocket through the center of the ball that you want to hit in.
You mean like this?
Right. Yeah, hold it right over the center of the pocket and the center of the ball. Good. And the other one runs through the center of the cue ball to the center of where we want it to be when it hits the two. Can you show me where that is?
Huh?
Well, just put the cue ball where we want it to be when it hits the two.
Oh, you mean here on my line.
Right. Good. See, wherever the cue ball strikes this ball, it'll knock it in the exact opposite direction. Okay, roll it back to me. There. Why don't you try it? There you go. Okay, go ahead. Oh, wait a minute. Now, let me give you a little better angle.
A better angle?
Yeah, something a little more in line with the pocket.
You mean there are all different kinds of angles?
Oh, you bet. Yeah. If you measure all those angles, you'll get all different numbers of degrees.
You mean angles of different temperatures?
Oh, no, not like Fahrenheit or Celsius degrees. No, it's a different kind of degree. Here, I'll show you. Okay, see the space between my fingers?
Uh-huh.
Okay, that's an angle. And this one doesn't have very many degrees in it.
How many?
Oh, it's about 20, I guess.
I don't see 20 anything.
All right, picture it this way. Okay, you've got 360 degrees in a full circle.
Why?
Well, because that's what the mathematicians agreed on a long time ago. If you take that circle and you divide it into 18 equal pieces, then each piece will have 20 degrees in it, and that's about like that, isn't it?
Yeah.
Now, if I move my hands apart, there'll be more and more degrees in the angle between the lines.
How many is that?
Well, that's about 90. Now, you'll notice it's a fourth of the way around the circle, and a fourth of 360 is 90. Okay, if I keep going around to halfway around the circle, how many degrees is that?
Half of 360 is 180?
Very good, right. And come around to here, how many is that?
90 again?
Well, it's 90 on this side, but what about on the big side of the circle?
Well, it's about 180 plus another 90. 270 degrees?
Very good. All right, swallow up that last 90. Come full circle, what have we got?
260?
Bingo. Now all you have to do is learn how to shoot.
An important thing to remember about measuring angles and degrees is that you're not measuring distances. What you're measuring is rotation around a point. The further the one line rotates away from the other, the more degrees there will be between them. And once you come all the way around that circle, that's 360 degrees.
What if the lines didn't go all the way out to the circle, but only went out to here?
Oh, it doesn't matter how far the lines go out. The only thing that matters is where the lines meet. You can measure the angle anywhere in the lines and it'll stay the same. Okay, everybody dig down on feel, lift your arms through the center by rhythm, then pull your hands into your chest and back out on of the night. Okay? Okay. All right. 5, 6, 7, 8. Feel the beat, the rhythm of the night. Pretty good. But make sure your arms are straight out.
You mean like a 90-degree angle?
Yeah, right, Chelsea.
What's a 90-degree angle? It's when one line is pointing straight out from another.
Like when our arms are pointed straight out from our bodies?
Right.
Okay, next, do a couple step-togethers and make a circle so your arms are down on light. Kenny and Chelsea, you take bigger steps than Rosita and Jeff. I'll just do mine in place. Okay, from the top.
Feel the beat and the rhythm of the night.
dancing till the morning light. Good, Chelsea, you got way out there. Kenny, big steps.
How big?
Well, you should be in a line from me through Rosita.
Your lines just swing out at about half of 90 degrees. So our two lines are about 90 degrees from each other.
Hey, neat. So this arm is at the same angle from this arm as our arms were before from our bodies?
Right, 90 degrees.
Guys, can we please get on with this? Okay?
Okay.
All right. You guys with your right arms and you guys with your left. Forget about the worries on your mind. Okay? Together now. Forget about the worries on your mind. Good. But, Rosita, bring your arm higher so your hand can come straight to your forehead.
You mean this has to be 90 degrees? Right. So this has to be more than 90 degrees. Got it.
Guys, can we please get on with the dance moves? Okay?
Okay.
All right. Next, you're going to extend your arm out on you can, then swing it all the way back and leave them all behind.
How many degrees does that swing back?
Well, from all the way front to all the way back is 180 degrees.
How do you know that? Because it's 2 times this, right?
Right, and in other ways it's because the whole circle is 360 degrees, and it's half of that.
Oh, so there's 4 of these in a circle?
Right, 4 times 90.
I don't get it.
Don't worry, Kenny, just do the dance. Okay, next we're going to repeat the first motion. Dig down, lift your arms through the center, bring your hands into your chest and back out. Okay? Ready? Feel the beating rhythm of the night. Okay, now the word rhythm in the next line, we're going to spin all the way around to face each other. Okay? Let's try it. Oh, the rhythm of the night. Good. You guys, don't spin to face the audience. Spin to face them.
But you said to spin all the way around.
I said to spin to face each other.
You should have said to spin 3/4 of the way around.
Yeah, that'd make you face us. 3 times 90 is 270 degrees.
Why didn't you say so?
Well, excuse me.
I still don't get it.
How about we do math class later? This is show choir, remember?
Okay.
Okay? All right. Now, on the last, oh, yeah, turn toward the audience and bend all the way out to the side and extend your arm out.
Should our arms and bodies be on the same line?
Yeah, your body should make a line.
What angle should we be to the ground?
Will you just look at me? Oh, yeah.
Oh, about half of 90 degrees. Why didn't you say so?
I'm never gonna get it.
Oh, brother. Angles that are easy to picture, you can estimate in your head. But what if you want to measure 37 degrees, or 174 degrees, or 256 degrees, and you want to do that very precisely? Then there's an instrument you can use. It's called a protractor. It looks like this. Actually, there are different kinds of protractors, but the main idea is the same in all of them. We're at the office of a man who works with angles in his profession. This is Bart Choi, an architect in Los Angeles, California. Bart, could you please explain how the protractor works?
Sure, Joy. This is a protractor, and it has angle markings on it from 0 to 90 degrees over to 180 degrees. Back the other direction from 0 back to 180. We measure angles by using a protractor in this manner. Let me draw a couple of angles that are generated by the intersection of 2 lines. And we set our protractor so that the crosshairs are right at the intersection of the 2 lines, and we're very careful to line up the 0 point on one of the lines. And in this manner, we're able to measure an angle fairly accurately. What angle is that, Jai?
It looks like 28 degrees.
28 degrees. Yeah, I think so too. Now that would be the acute angle, an angle that's smaller than 90 degrees. And we can measure the other angle, this one over here, which is much greater than 90 degrees. And Joan, can you read this angle over here?
It's about 152 degrees.
That's right. And if you add these 2 angles together, these 2 numbers, you come up with 180 degrees, which is half a circle.
Aren't most buildings 90 degrees, or can you use different angles when you're doing architecture?
Things that are straight up and down are stable. They're 90 degrees to the earth, and they stand upright just like yourself. If you lean a little bit too far, you fall down. And the same with our buildings. We make our buildings straight up and down, and we make our rooms, for the most part, square-like. And this is what you've observed. But in this particular house, this is a floor plan of a house we did in Malibu. We have one large, prominent wall here that's on a 45-degree angle. And this angle points out to the ocean view. Let's see, here it is, and that's just how it's oriented towards the map. And here's the drawing, and there's the angle wall and all the big view windows that orient out towards the ocean. And these rooms up here, the dining room over here overlooks the living room. And actually all the spaces inside here kind of look out along that wall. So that wall is a very important part of this house.
Where else in architecture do you measure a lot of angles?
Well, let's see, we use angles a lot. We have to concern ourselves with angles when we involve ourselves with the sun angles, what we call solar angles. In this case, we have to know exactly where the sun is, or I should say maybe exactly where our house is, or our building is, relative to the sun. Now I'm going to draw a picture of a simple house. And we'll put Johnny inside here somewhere with his striped shirt. Because of where we are in the world, in Los Angeles, in the wintertime, we know that the sun comes in at noontime at about a 34-degree angle. And in the summertime, we know that here again in Los Angeles, that the sun comes in very high at about an 82-degree angle. And with that knowledge, we can devise or design this roof overhang to shield out the sun when it's very hot, or let the sun come way into the inside of the house, through a window, of course, all the way to the back of the house. That then lights the house when it gets darker in the wintertime, and adds a lot of warmth to the house.
Remember that on a protractor, the crosshairs have to be on the point where the two lines meet, and one of the two lines has to be on 0 degrees.
The shape of the bottom part looks close enough. Yeah. Ours may be a little bit taller, but once in a like this one. Okay, let's make the pieces to put the roof on.
Think we can cut both the front and back out of this piece of plywood?
Easy, especially if we cut one triangle up this way and one down like this.
Okay, so this will be the bottom of one piece.
How long should it be? "69 centimeters.
Now how do we figure out the other two sides?
I'll use my protractor to measure these two angles on the model. Then you measure those same angles over there.
Are you sure we can go from that little one to this big one and not change the angle?
The angle stays the same no matter how far out you go. See how these angles are 90 degrees and those are 2, even though this is a lot bigger? Okay, I'll make sure that the bottom line here is right on the 0-degree line of the protractor. And let's see, this point on the protractor has to be right where the two lines meet. Now I have to be sure to pick the right number. Is it 45 degrees or is it 135 degrees? This angle is less than a right angle, so it must be 45 degrees.
Gotcha. Let's see. 45 degrees. Do I just measure 5 little marks away from 40?
Yeah.
Is this the right 45 degrees? Or is this 135 degrees? Which way's down?
Kenny, there's something I'd better explain to you.
What? What do you think?
This program was supported in part by the National Science Foundation and was produced by John Allman and Art Fitzsimmons, under the supervision of the Agency for Instructional Technology, AIT.